Hi, everyone. I think 5 minutes is fair enough for waiting. My name is Huseyin, and in this session, we are gonna deploy a Kubernetes cluster from scratch onto the DigitalOcean by using some new fashion technologies. By the way, I hope all of you can hear me. If you can, please ping on the chat so I can continue with my slides.
Yeah, we can hear you.
Yeah, okay. Thank you. So in this session, we are going to use Docker machine for deploying some droplets on the DigitalOcean cloud. So we will have one master node and the 2 slave nodes in order to have a minimum cluster size for the Kubernetes. And also, since this is a from scratch session, we will install kubelet, kubeadmin, and the kubectl by ourselves. So what are those technologies? Most probably you know the Docker machine, so I'm not gonna provide the information about that. So can you hear me?
Yeah.
Okay. So kubelet is, you can think about that this is a daemon, and then it controls the pod lifecycle. We will use kubeadmin in order to install our cluster onto DigitalOcean. So we will initialize a master node, and then we will initialize slave nodes in order to have a cluster. kubectl for the client in order to do some operations on the Kubernetes API. So let's get started. On DigitalOcean side, first of all, you need to have DigitalOcean account, and then after you grab some access token from there and expose them onto your local computer, we will be able to create our machines by using Docker machine command. So you can provide those parameters on the fly while you are creating your machine, but also you can provide this one as an environment variable and then continue with your Docker machine commands. So let's create our cluster members. Okay. So this is our first member, but sorry, in order to continue that, I need to expose my environment variables first. So this is our master master member for Kubernetes cluster. Once you execute this command, as you can see, we will have this droplet is about to start. So it is spinning up. At the same time, I will execute 2 more. Here, I will say Docker machine create. This time, this will be node 1. And then I will create another member. So we have a master node that already spinned up, and then we need to wait for the rest to be started. I am deploying by using Docker machine because I don't want to handle with these SSH keys or some password in order to jump into the servers. So it will be very easy to do that by using Docker machine commands. So once we finished with spinning up the server, we will continue with installing kubadmin and kubelet and kubectl. Those components needs to be installed there, and we will enable them as daemon in order to operate something on the background. By the way, during the spinning up session, let me provide you another information for this. Most of the time, we do not install Kubernetes cluster from scratch. So we do this. For example, if you are using AWS, 1 year ago, for example, we were using kops, which is a cluster management tool for the Kubernetes. But now, recently, AWS released AWS Kubernetes service on their environment, so you don't need to do anything. So you can set up your cluster by clicking a couple of buttons there. For example, if you are using Google Cloud, also there you can create your Kubernetes cluster. It is built-in feature there. Also in Azure environment, you can use Kubernetes Kubernetes container engine on Azure platform. And yeah, you can do that like this. I am providing this from scratch session because if you know this very well, you will be able to do anything on any kind of environment. So all of the machines are ready right now. And then let me install some packages to this service one by one. In order to jump into the master member here, I will use docker machine SSH command, and also here machine one. And yeah, we are in on all of servers. So let's start with the first one. In order to install those components, first of all, I need to update my repository cache. Okay. And then I will add some keys in order to be able to download some third-party packages. This is okay, this is okay, and also this is okay. And I need to add some repository to my package. By the way, I will provide this step-by-step document to you. I will share, so you can have a look at and then do it by yourself. Okay. I think we are able to install these packages right now. So kubelet, kubadmin, and then kubectl. We are setting up this cluster in order to deploy our containerized application to this one, right? We are using Docker. So when you say Docker, you need to know that what is C group. So in order to have successful cluster, you need to be sure about that Docker and the kubelet are using the same C group type. So in order to be sure, I will execute this command for one member first. For example, here, as you can see, C group FS is used for the Docker one. And let me check the kubelet. So here, once you install the kubelet, you will see that there will be some file like this. And when you check this, actually, let me grab C group, something like this. As you can see, there is no member here. So it means they are using different C group technologies. So in order to make them in the same page, I will execute this command. So both of them will have same C group technology there. We have installed our packages, and let me reload the system for all of them. And then let me restart the kubelet. Kubelet is very important part of the system, because in order to make your pods down, up, or assigned to some node, you need to have these installed successfully. Okay, so what now? Let me show you the some image about this structure. So we have 3 members right now, and we have installed this onto the DigitalOcean by using Docker machine, right? And also, right now, we will initiate a Kubernetes cluster. In order to have a successful Kubernetes cluster, you need to decide on the container networking interface. This is an important part of the system again, because in order to make your pods communicate between each other, you need to use some third-party plugins in order to do that. For example, I will use, in order to initialize a cluster, you need to execute kubectl init, but I will provide another parameter here. Then this will be required by our CNI plugin. So let me execute this command. If you set up a Docker Swarm before, it is very same with this. First of all, you initialize a master node, and then you will be provided with a URL or command, and you will be able to execute that command on the slave nodes in order to connect them to the master node. So I will provide you some page in order to see what is add-ons. So we need to handle this one, networking and network policies. So you will see some plugins here. I will use Calico in order to make it simple. You can see lots of plugins here in order to install on your system. So all of them has their own strategy, so you need to have a look at the documentation in order to do that. So in order to use Calico for this, I needed to provide my CDR interface with this mask, okay? That is provided by their documentation. As you can see here, once you initialize the master node, it says that, okay, initialized successfully. And then if you are using regular user, you can use this command in order to store your configs, cluster configs, onto your home directory. Now, you need to install this CNI plugin on the master node, and then you can join your members by using this command. But before doing that, let me create my configuration by using root user. So since I am the root user here, I can export this command. So when you operate the kubectl command, it will look at this, look at the location that provided as a value for this config, okay? So when I export this, and then when I try to execute some kubectl commands, I will be able to access my Kubernetes cluster. So I exported this one, and in order to install CNI plugin, I will execute this command. So what is this? There is a YAML definition here, and I need to apply this definition in order to make pod communication active. So first of all, before that, please store this command on some place, because we will need to use this one on slave nodes. So let me save this one. Okay. And when I apply this command, as you can see, some daemon sets, services, deployments, cluster roles, blah, blah, blah. All of these components are already a Kubernetes component. So we will be, by the way, we will be provide some extra webinars in order to explain these component properties, but let me continue with installation first. So how can we check this one, if it's running or not? When you try to list all the pods here, you will see Calico add-ons. You need to see etcd, but the most important one, you need to have this kubedns DNS part. So what does it mean? Once you spin up a pod or some containers or some services inside your Kubernetes cluster, they will have some initial DNS records by using this kubedns service. So in order to continue with the installation, you need to be sure about that all of the components are up and running. So we need to wait for this one in order to continue. It's still pending. By the way, for the C group part, we have only execute this one on the master node. So in order to be on same page, I will execute this command for the others. This one. Yeah, now all of them are same. Let me check this one. It's still pending, so we need to wait for that. What else? For example, I am using 4-member Raspberry Pi cluster on my home. So in order to install Kubernetes cluster there, you need to follow this procedure, okay? So not all of the time you will be able to install this one as a provided service like AWS, Google Cloud, or Azure environments. So it's still pending. We can check this one like this. For example, my kubectl client is functional. So here, as you can see, I am able to list my nodes. So when I said get pod here or get po, doesn't matter, you will see nothing because it is using a default namespace. But when I say this one, kubesystem, namespace is kubesystem, you will see all of them, right? So let me inspect this pod. What is going on here? So this will be not get po, so describe po. So it says that failed to schedule before 22 seconds ago. Insufficient CPU. This is still pending, so I will do this one. Kubectl reset. Okay, I will do a fresh start for this. So what was the commands? I will need to initialize my cluster by using this CDR network. Okay, it seems it is initialized again. And then since I am the root user, I will export my command again in order to be sure. And I will store this command in order to use in the slave nodes. And my final part is applying So this is not ready yet. Let me wait for this and then execute my command. So this is running. So all of them are created right now. Get policy. So still pending here. I need to wait for that. First of all, I need to check the property of this one. Let me increase the size memory of this one. Yeah, but 1 GB is the default value. By the way, I have already set up this cluster by using that size, and there was no problem. But since it says there is insufficient CPU, I needed to increase that first. If that doesn't work, I will create another machine from scratch, so we will be able to eliminate this problem. So we have powered off this system. Then let me do that 3 GB. So the resize is completed. Let me power on again. Yeah, this has the simplest interface within the cloud providers. I like the DigitalOcean. So I think we are able to access our machine. Yeah. So we have 3 GB here. Okay. I will reset the system here and then initialize the system again. Okay, so traditionally, let me export the parameter again, and then let me store this comment. So we will apply our plugin again, but let me kubectl get node. It says simply not ready. And then, so here we need to describe. I think I need to change my CPU too, but I don't know why it's giving this error. This time I will power off the machine and then provide another CPU for this. So there will be 2 vCPUs. This. So what else if I initialize my cluster onto this one, for example? I will export this. Let me store this command. Okay, and then let me apply this. Not ready here again. So I will power off the machine again. Access, power on. So I assume there will be no problem about CPU. Yeah. So since we have started this from scratch, okay, so now we are ready to initialize this one. So yes, I will grab this one. Then not ready again. Yeah, this time it is running, but yeah, it is running and increasing. So DNS is running, so no problem. And it means I have spin up this 1 GB instance several times, and it worked. Since we are on the webinar, it is very normal to sucks, right? So no problem here. We have 2 vCPU member here. As you can see, all of the pods here are running. So we can continue with the joining part, right? In order to join your members to the master node, you need to execute this command on every member. So as you can see here, this node has joined and they have replaced their certificates between each other. Also, let me grab this one. It's B, yeah. Yeah, all of the members are attached to the master node right now. I will execute kubectl get node. 2 of them are ready, and we need to wait for not ready member, and that will be done successfully. By the way, by default, the master node is protected. That means, yeah, you are very right, Luna. You can use watch parameter in order to not execute one by one again and again. Yes, you are right. You can use watch parameter. And what I was saying, yes, by default, the master node is protected. That means you cannot schedule anything to on that node. So in order to, this is called master node isolation. In order to remove that protection, that means you can schedule your pod services on the master node, you can use this command. Yeah, there is a status called retain. So this ain't the there is something missing here. Untained. Yeah, okay. So yeah, we have 3 members here, and 1 of them is master, 2 of them is node. We have joined our where to use. Yes, for example, let's say that kubectl get node, and not node, for example, get po. For example, in order to check the status of the pods, we execute this command. So when you say this one, it will get the result, but it will get result periodically. For example, if some of the pods here goes down, you will see right in here. It is something like watch command in the Linux. So you specify the periodic frequency, for example, 1 second, 5 seconds, and then your command will be executed periodically instead of doing that manually. So what is our picture right now? Let me show you. So we had machines here. We have installed our Kubernetes. So what is next? As you can see here, we are using kubectl command on the master node, right? On real world, we do not use kubectl inside the master node. We use some other laptop or other managed service, and we are using kubectl within that service. Let me open another window here. I am here right now. So what can I do in order to use kubectl command here, using here? So since we are using Docker machine, it will be very easy to copy some configurations within my computer. I am saying here that Docker machine SCP, and then I am providing my machine name, which is Kubernetes master, and then I am providing the path. My Kubernetes config exists in the etc Kubernetes admin conf, and then I will provide my destination. Let's say that so when I do this, as you can see, I have this configuration, right? So in order to, you can do this. You can put this configuration under your this folder .kube/config here. This path is used by default by the kubectl client. Also, you can provide this parameter on the fly. So I will say that. Also, you can provide kubeconfig and then your file, as we did on the cluster. But here, I will say that, what was that? This one, conf and get nodes. When you do this, as you can see, yes, I am able to see my nodes by using my local computer. So there is no need to make this open. So the control is mine after this time. So what else? We have installed our cluster. We have configured our client, kubectl client. And there is another component in Kubernetes world called Kubernetes Dashboard UI. So you will be able to see your exact system by using this application. This application is a Kubernetes application, so it will be enough only if you only provide, let's say that this one. So with this command, we are applying the specification defined here. When you open this file, let me show you here. So it is redirecting. I need to check that again. So within this file, there is some deployment specification, service specification, etc. Once you do this, you can open this by using proxy command. So when you say this, your local URL here will be proxied to entire cluster within the DigitalOcean site. When you go this URL, you will see your Kubernetes dashboard UI. But within the recent Kubernetes release, the authorization component enabled by default. In order to eliminate this one, this is not secure, by the way. I will do this. I will create a within here, for example. Let's say that I am under the temp folder. I will create a file here called dashboard admin YAML file. Within this file, I will provide a cluster role binding. This will enable my user in order to access this dashboard. By default, it is protected, but I will enable this one for now. So kubectl apply -f and dashboard admin. Yeah, I didn't provide my not that. Okay. So as you can see here, cluster role binding is applied. Okay. When I refresh this page, you will see your entire cluster review here. So let me go to the main page. When you click nodes, you will see your node member here. You can see the namespaces. As you can see, there is kube system, kube public default. You can see your pods, or you can see your, for example, when you go to this kube system, as you can see our Calico add-on used for the CNI networking. So what else? We have, right now, we are here, right? We have set up our cluster, we have dashboard UI, so we are good right now. Let's switch to some development part. We have said that we will deploy some application to Kubernetes cluster, right? I mean Spring Boot application. Here I will say, by the way, I am using Spring CLI, which is used for creating some projects. Here I am saying that initialize a Spring project that have dependency to web and actuator, and the name will be DevOps Underground right now. When you do this, you will see some project here. In order to deploy my project into Kubernetes cluster, I need to create a Docker image for this, right? So I will create a Docker file within this folder, and I will add very simple Docker image definition here. So I will use OpenJDK, Alpine. I will add the jar file within the Docker image, and then I will execute java-jar that space app jar. Here, but in order to do that, I need to build this first, Maven clean package. This will create a jar file and will put that into the target folder. So by doing that, I will be able to add my jar file into the image with Dockerfile specification. Let me build my image within my folder. So I created my image, and then I will push this image to Docker. So yes. So I logged into the Docker hub, and then I will be able to push my image to remote Docker hub. It is preparing. Once we push this application to the Docker hub, we will be able to run this by using some imperative commands. In order to deploy some application into Kubernetes environment, you can use imperative commands and the declarative commands, declarative configurations. Declarative configuration is the one that you can define your specifications in the YAML files. You can define deployment, services, etc. But with the imperative commands, you can deploy your application within the cluster right away by using some on-the-fly commands. So let us push this image to the Docker hub, and then we will come back to the deploy pod part. As you can see, the image is very small. There's another layers, but it is very near to this number. While we are waiting for pushing, you can ask your question on the chat panel also, or you can unmute yourself and then ask your question. It is very slow, but finally it will finish. Yes, it is currently recording to the cloud, so we will provide this URL. Plus, I will provide my step-by-step documentation with you. But you can, maybe you need to change your names or etc. Yeah, I think our image is ready, so maybe we can try this image, right? Docker run. We will expose 8080 port. And then what is our image name? This one. So when you do this, a Spring Boot application will spin up, and then we will be able to go to the URL. Yeah. So when you set curl http localhost 8080, since we added actuator, we will be able to see some endpoint, for example, health. So status is up. So that means our image is working correctly. I'm closing this one right now, and let us deploy our image to our, let me do this one. This is an imperative command for the Kubernetes environment. This will create a pod. One sec. So, yeah. Here, this will deploy our application right in the Kubernetes cluster. This is an imperative command because I am providing all of the parameters here. So when you say kubectl and get pod, you will see our pod is on the Kubernetes cluster and it is running. But this does not mean that you can access this application. So we need to expose this deployment to the outside by using this system. For example, we will expose pod. We will expose pod for the port 8080, and then this will be a service type node port. That means this application will be exposed to the outside. So when you set 8080 and type node port, this port will be available for the entire cluster members. We used wrong name here. our pod name is this one. And then, yeah, we have exposed our pod to the outside publicly. So that means we will be able to get our service definition, right? As you can see here, we have a service, but it is node port, and the node port is automatically assigned to this one. That means grab one of the public IPs of your member. For example, in our case, let me grab this one. And then when you say curl HTTP this, and our port is this one. When you say this port, when you make a request to this port from any of our cluster members, you will get same application. Health, actuator /health. As you can see, the status is up. But under normal condition in the production environment, we are not using this system by using node port in order to make this available to the outside. On the normal flow, we are using load balancer type. So, or we are creating some ingress in order to redirect the outside request to the within the cluster. So since our scope is only create a cluster from scratch and then deploy a sample application to this world, I try to keep it simple. So hope you understand it very easily. So we have created a cluster and we have application, and our image is like this. It is very cool. And then let me refresh this page and see what's going on here. And not kube system, within the default namespace, you will see your pod here. And also when you go to the services part, you will be able to go and see your service. And when you click pods and the description part, you will be able to exec and also see your logs. For example, when you click logs, you will see your application logs. And also when you do an exec, it will be a simple exec into the container. But since we are using Alpine image, the bash didn't work, but I think it tried an sh command and the application is working. As you can see here, pubjar exists inside the image. And that's all. You can ask anything, any kind of question for this. You can, for example, any kind of question you can ask. I will be able to answer your questions. Also, you can trace your events here. For example, the default scheduler is scheduled this. So onto the master node, and then the image pulled, successfully pulled image, and the created started container. This is very simple tracing log. Yeah, I can show here, kube system. And then pod. Yeah. Yeah. This is very good question. How would you link allow communication between pods? So actually, the communication between pods, not a correct term. For example, when you create a service, create multiple services, you will be able to see you will be able to connect these by using some alias. For example, let me provide you an example for this. For example, within this pod, when you exec into the container and do an env command, you will see that there is some parameters here, right? So if there is another service within this cluster, you will see the information within the environment variables for that. So the service name will be the host name that you will use for the communication. So there is user service and there is product service. If you are trying to connect product service from the user service, you can use product-service to access another pod within the service. So you will use name for the communication. But also, if you create your service as node port, for example, you can use localhost and then the port part for communication. Also, in order to communicate pods between each other from different namespaces, you need to use this notation. I am writing down here. For example, you are trying to access user service within the namespace app from the default, for example, you need to use this one. Product service.app. If you are trying to call product service from the user service, you need to use this notation. But also, you can use this one, localhost. And if you define your service as node port, you can use blah, 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 whatever port is available. So I have shown you the kube system MC. Will you ask a question about this? So here is the pods. Okay. So etcd is the key value store. Kubernetes uses this one in order to save state for the cluster. And also this API server is the API, entire API. So when you do something with kubectl, actually you are communicating with this one. This scheduler is the important one because this schedules the object within the valid or available node. Also, what else here? This controller manager controls the other controllers. There are different kinds of controllers within the Kubernetes cluster. This is the manager of the controllers, actually. And this one for pod communication. DNS part is not here, but I need to check that. DNS here and kube system. So yes, what is not showing in the dashboard? There's 3 replicas. Maybe So it is in which namespace? Which one? This, yeah, this one. It is in the kube system, but it is very strange. It is not showing up within here. No, maybe there is a filter here. Ah, there's another page. Yeah, yeah. Okay. This one. So I am not used with Windows, so I will not be able to provide any comment for that. But in order to have Kubernetes cluster successfully, you need to have certain conditions about operating system. For example, there is different type of installation for different type of operating system. So I have used Ubuntu, and it is very easy to install there. But if you have Windows or something like that, by the way, I haven't seen any instruction for the Windows. In order to have this, you need to some certain operating system. But again, because it was more around. No, I have no experience with that. Most of the time in Kubernetes world, we are not using Docker commands because once you have a successful Kubernetes cluster, after that time, you will use Kubernetes specific commands with the kubectl. For example, what we are doing here, I have deployed my application to the system, and then I am trying to, let's say that one of my application is not reachable by the users, end user. At that time, I am using kubectl get po, and most of the time we are using specific namespaces, but this time I am using default namespace. So this is running, right? Sometimes this might be running, but once you close this one, it may fail again. So you can check this age and then restart part. If you see lots of restarts here, for example, 15, you need to be careful about this one. So I am grabbing this pod name and then kubectl logs-f. And this time I am checking my logs. But this is a very basic operation. In general, we are using centralized logging system. That means all the logs from the application collected and they pushed some centralized logging system. For example, you can use Fluentd, and Fluentd sends your logs to the Logstash, and then after that, you can send your logs to the Elasticsearch in order to visualize that on Kibana. But if you want to make a quick debug manually, you can use kubectl getpo, or by the way, you can, but most of the time, you can see this. When you say getpo, there can be another status here, for example, crash loopback, or container running, or container creating, etc. In order to get broader explanation for this, you can do this one, kubectl describe, and provide which component you want to describe. Kubectl describe for this one. When you set this, you will see all the metadata of this pod. As you can see here, there is events section. So once you have a problem with the pod, you can see the error section here. Most of the time, maybe there's a permission error during the pooling phase, or you can have some problems about using secrets, etc. There are lots of operations here, but there is a cheat sheet for this. For example, kubectl cheat sheet. When you open up this one, you can see lots of useful comments. For example, there is lots of topics here about rolling update, exposing services, labeling, selectors, etc. But you can have a look at here in order to find some basic comments. Yeah, for example, here you say that, okay, get me the pods, give me the pods that have these labeling system, for example. You can tag your deployments and then you can query them by using this notation. What else? Any other questions? Yeah. Yeah, you can do that, but yeah, we will share the video and share the documentation also. About the question MC provided, when you increase the certain amount of the worker, you need to use some distributed master system. For example, here I have used only one master, but when you increase that number to, for example, if you have 1,000 worker machines, you need to have multiple master nodes. And in order to make them communicate, you will use etcd in order to make them communicate. But yes, this technology has been using by Google for several years. The name was not Kubernetes, but that was another name within the Google company, and they are starting and stopping billions of containers within the day. I think you are very good to use Kubernetes with thousands of worker machines, but you need to have several master nodes in order to have this kind of cluster. You're welcome. In order to learn the basics, you can use this from scratch, but if you are doing something quick for your POC project, please use some environments like AWS, Google Cloud, etc. This is very experimental. This is for very experimental things, creating from scratch. I haven't checked it, but in the specification it says that you need to have at least 2 gigabytes of something like that. Let me check and provide you the information. Yeah, it says that you need to use 2 gigabytes of RAM or more, and then you need to use 2 CPUs. I have already used one CPU on DigitalOcean and it worked. That was the reason of failure. You need to use at least 2 CPUs or more for the master node. And the memory is 2 gigabytes. Yeah, we will do some advanced webinars for this. By the way, we are doing some surveys in order to decide the next webinar topic. For example, this Kubernetes from scratch decided by our audience. And right after this webinar, I will create another survey and send to you. Please make your choice, and then within the 1 week, we will decide on the next webinar topic. There will be more advanced one about load balancing. When we say load balancing, persistency, etc., we need to use some cloud environment. Also, if maybe, for example, for one webinar, I will use Google Cloud, and for another webinar, I will use AWS in order to show you different kind of cloud providers. Yeah, because once you use Kubernetes, you need to set up several things for that. For example, logging, persistency, those are the important topics, and you need to have all of them in order to have successful application architecture. And also, if you have any topic for this, it can be Kubernetes, some cloud specific, or it can be about software development. You are very welcome to make a webinar within the DevOps Underground meetup group. Yeah, I think, yeah, this is the URL. You can ask your questions later. Yeah, you can ask your question later also. You can write on the meetup group. I can happily answer your questions. Yeah, this is our Twitter account. You can ping us on there also. Here. Yeah, thank you all coming to this session, and have a nice day, have a nice night, or whatever time zone you are in. Bye.